It's your friendly math tutor, Miss C here, and today we are talking sine functions, specifically how we identify transformations in equations when multiple are present, and then we're going to take it a step further and solve equations with multiple transformations. We are starting with y equals 3 times the sine of quantity x minus 70. So I see two transformations. One is represented by the number 3 here, and the other is represented by a change in the parentheses. Remember, our most basic sine wave looks like this. Y equals the sine of x. That's how I know that the 3 and the 70 represent transformations. So let's start with the 3. The 3 represents our amplitude. So we would say that this equation or this function has an amplitude of 3. An amplitude is a vertical stretch. That means that our maximum, which is normally 1, and our minimum, which is normally -1, grows by 3 times. So that means our new minimum is -3 and our new maximum is +3. Our graph has been stretched such that it's taller. We also have a phase shift, and that is what this part of the graph tells us. So in this case, the way we calculate phase shift is we figure out what value x, or our variable, has to take on within the parentheses to make what's inside the parentheses 0. In this case, x has to take on +70. In math, a positive number shifts our graph to the right, and it shifts the whole sine wave 70 degrees to the right. I have videos on both amplitude and phase shift that go into those explanations in much more detail and provide much more practice. So check those out if you need more detailed explanation. All right, our next equation, y equals half times the sine of quantity x plus 45. We have an amplitude of half. That means our graph has shrunk down. It's shorter than the original function y equals sine of x, placing our new minimum at -half and our new maximum at +half. There is also a phase shift. Remember, we are looking at this part of our equation. What value makes x, or what value makes of x that makes that part of the equation 0? In this case, x would have to take on a value of -45. In math, a negative value suggests that we move in the negative direction or left. So that means our phase shift moves our graph left 45 degrees. And finally, we have one that is a little tricky. So we have y equals -5 times the sine of quantity x plus 10. This is a tricky one because the negative is not part of our amplitude. So our amplitude is 5. So we'll get to the negative in a second. So 5, an amplitude of 5 means our graph is stretched by 5 times its original value, placing our minimum at -5 and our maximum at +5. And this negative value, this negative sign right here, tells us that our graph is reflected about the x-axis. That means every value that was positive is now negative, and every value that is negative is now positive. So it's flipped upside down. So if you study quadratics, it's like when y equals x squared has a negative in front of it, it turns the parabola upside down over the x-axis. So that's what's happening here. We also have a phase shift. Be 10 degrees. A phase shift that shifts our equation left 10 degrees. Remember, we're making this 0. X has to take on the value of -10. When we do that, our graph shifts 10 degrees to the left. Let's solve some of these problems now. All right, we're going to tackle our first problem. We have 4 times the sine of quantity theta minus 35 equals 3. The graph is here. Before we get started on that, we're going to identify the transformations just so that we can see what's happening. This 4 represents our amplitude of 4. That means our graph is stretched by a factor of 4. That places our new maximum at 4 and our new minimum at -4. That's about here. Oops, definitely not right there. It's about right here. Boy, I'm not doing very well. And right there is our minimum, and we have a phase shift. So remember, phase shifts happen when whatever's in the parenthesis, the variable takes on to make 0. So in this case, theta has to take on +35 to make what's inside the parentheses 0. Positive numbers in math shift our shift to the right. So this sine wave shifts to the right 35 degrees. So we can see that our graph starts about right here. So if we trace this sine wave, we're going to see our full wave happens right there. So it starts at 35 degrees and ends at 395 degrees. So I went ahead and placed y equals 3. That's what this blue line is here. Y equals 3 here because that's where we are finding our solution, where that line intersects with our sine wave. So we can see that we're going to have one solution here and one solution here. Again, we're still seeing two solutions within 180 degrees, though that 180 degrees have shifted from 0 to 180 degrees to 35 degrees and 210 to 215 degrees. All right. So let's go ahead and solve. So the way we solve is we try to get sine of whatever's in the parentheses by itself. That means we start by dividing by 4 on both sides. When we do that, we end up with sine of theta minus 35 equals 3/4. Then we're just going to take the inverse sine of both sides. When I do that, I'm left with what's inside the parentheses. And then we have the inverse sine of 3/4 here. Okay, the inverse sine of 3/4 is 48.59 degrees. Make sure that your calculator is in degree mode here. Okay, and at this point, we've got to set up our second equation. I'm going to run out of room here, so I am going to slide this up a little bit. Our second equation identifies that we are going to have two solutions within 180 degrees. So we say theta minus 35 equals 180 minus the solution we just got, which is 48.59. We're going to come back to our original solution here, and we are going to continue solving for theta. So I'm going to add 35 degrees. And when I do that, I get a solution of theta equals 83.59 degrees. If we look back at our graph, that's the solution right here. Okay, now we're going to pop down to our other solution that happens within that 180 degree span. So I'm going to go ahead and simplify the right side of my equation. And when I subtract 48.59 from 180 degrees, I get 131.4. And now I'm just going to get theta by itself by adding 35 to both sides. When I do that, I get theta equals 166.41 degrees. All right, and that is this value right there. So those are our two solutions. When you are solving these equations on your own, you're probably not going to have the graph. So I would always recommend, and if you watch my videos, you know I always recommend checking your answers. The way that you do that is in your calculator, you type 4 times the sine of, I'm going to put our first solution in, just like this. And you should get out approximately 3, right? Because our equation equaled 3 when we started. That's what we should get out. And it's approximately because we rounded off 83.59 degrees. And then you should do it with this value as well. You substitute that where you originally substituted 83.59 degrees for theta. By the way, this second value tends to be the most often incorrect value because people often apply that 180 degree property wrong. So definitely check your second answer, if not both. All right, let's move on to our next problem. All right, we are on to our next problem. So let's start once again by identifying our amplitude, which is 2/5. You can see it's this number right here. And in this case, we have that places our maximum at 2/5. I'm not having a great luck writing here, and our minimum at negative 2/5. So the graph is really squished together. And then to find our phase shift, we're looking at what theta has to take on to make what's in the parentheses 0, and it has to be negative 110. Negative moves our graph in the direct left direction. So we shift left 110 10 degrees. Okay, let's get oriented to what we are actually solving for. So our domain is quite big. We are looking at from negative 360 to positive 360. I've drawn vertical lines there in that glittery pen color to highlight that. And I just also wanted to point out that our graph, because it's been shifted 110 degrees, our wave starts here and goes all the way here. That's 1, right? And then we end up with a partial wave from here to here, right within our domain. And then we end up with another partial wave going from here to here. So we've got we've got 2 partial waves and then a full wave within our domain. And I once again put what we're solving for, y equals 1/10. I put a line there so we can see our intersection points. And let's go ahead and circle those. So we know we've got one intersection here, a little less than 300 degrees. We have another one here, a little more than negative 100 degrees. We've got one right here at around 60 degrees. And we've got a fourth intersection point there at a little more than 260 degrees. So we're going to have 4 solutions, right, that show where our graph intersects with the line y equals 1/10. So we're going to solve the same way we solved last time. We are going to get sine of theta plus 110 by itself. I'm going to do that by multiplying both sides of my graph by the reciprocal of 2/5. You can also divide by 2/5, but I love fractions and I would rather multiply by its reciprocal of 5/2. When I do that, I end up with sine of theta plus 110 equals, I'm going to cross reduce these really quick, of 1/4. So just as a quick reminder, whenever you are getting to the point where you have sine of whatever on one side and then you've got another value on the other side, the other value has to fall between 1 and -1, which 1/4 does. So that's a quick check that you did that right. And now we're going to go ahead and take the inverse sine of both sides. When I do that, I end up with theta plus 110 equals the inverse sine of 110. I'm going to not of 110, of 1/4. I'm going to remind you once again to make sure that your calculator is in degree mode because we are in degrees here, and you'll get a very different answer if you are in radian mode. So this spits out 14.48 degrees from our calculator. And now I'm going to go ahead and come over here and I'm going to apply our property that shows that we get 2 answers within 180 degrees when we have a sine wave. So remember, this only works on sine. It does not work on cosine. Different wave, different properties. So, all right. So we're going to leave that glittery color for later, and we're going to come back over here, and I'm going to get theta by itself by subtracting 110 on both sides. And when I do that, I end up with negative 95.52 degrees. Okay, that is one of our solutions. That's this one. Okay, at this point, we now need to apply our other property of our sine wave that says every value on a sine wave repeats exactly 360 degrees to the right or 360 degrees to the left. So knowing that my domain is from negative 360 to positive 360, I could subtract 360 degrees from this, but this is going to give me a value outside of our domain. I do know if I add 360 degrees, I am going to get a value within our domain, and that value will be 264.48 degrees. So that is this value that we talked about earlier. Okay, so those are our 2 values for that part of our solving. And now we're going to pop over here, and I'm going to simplify theta plus 110. And simplifying the right side of the equation, I get 165.52 degrees there. And then just like we did on the other side, I'm going to go ahead and subtract 110 because I am on a mission to get theta by itself. When I do that, I get 55.52 degrees. So that is this value right there that we talked about earlier. And once again, I'm going to use our property, the 360 degree property. So if I added 360 degrees to 55.52, I'm going to end up with a value greater than 360, and that's outside of our domain. But if I subtract 360 from 55.52, I'm going to end up with a value within our domain, and that value will be negative 304.48 degrees. That's a degree mark right there. Didn't turn out very well. And that is this value right here, 304. So these are our 4 solutions within this domain. I, again, recommend please check your answer by plugging all 4 of these values in for theta, and you should get out approximately 1/10 or 0.1. Let's move on to our final problem that has both an amplitude and a phase shift. Alrighty, so let's go ahead and get started. I'm gonna just note that our domain is pretty different on this one. We are going from 0 degrees to 720 degrees. So I'm gonna go ahead and draw that here. Okay, that's our domain. And we still have an amplitude change, and we have a phase shift, and this particular graph is reflected. So let's just go over what our amplitude is. It is 10. That places our maximum values at positive 10 and our minimum values at negative 10. Our phase shift, our graph that is shifted to the right 60 degrees because theta has to take on positive 60 to make what's in the parentheses 0. And the other transformation that we have is the direct result of that negative sign. And this is a reflection about the x-axis. All right. So what you're going to notice with that reflection is that instead of going up first, our graph actually goes down first. So we hit our minimum before we hit our maximum. So like every other problem we've done in this set, I went ahead and graphed negative 10 times the sine of theta minus 60. That's the wave. And then I graphed y equals 9 because that's what we're solving for. So we have intersection points with our line. I'm only looking from 0 to 720. So this first point here is less than 0. So that's not a solution. This is a solution. This is a solution. This is a solution. Boy, and this is just squeezing right on in, and that's a solution. So we have 4 solutions within this domain of 720 degrees. Let's go ahead and get started solving. I am going to divide by negative 10. Boy, my pen is not working very well today. Let's try that again. Negative 10. All right, when I do that, I end up with sine of theta minus 60 equals negative 9/10. I'm going to take the inverse sine of both sides. So I'm going to pop the inverse sine into my calculator of negative 9/10. Do not drop the negative. Otherwise, you're going to get a very different solution. When I do that, I end up with theta minus 60 equals negative 64.19 there. And because I now just have theta, I have whatever was inside the parentheses on one side and my solution on the other, I apply my 180 degree property. I'm going to run out of room here. Over there. So we'll solve the blue side in a second. We're going to go ahead and solve the pink side right now. I'm going to go ahead and add 60 to both sides because my goal is to get theta by itself. So that gives me negative 4.19. That was this first value that I drew the arrow by, this one right here, that I said, oh, it's too small. It's not a solution. That it's true. It's just not in our domain. So I'm just going to say not in domain. Okay. And so now I'm going to go ahead and we are going to apply our property that says this value will repeat in exactly 360 degrees. So I'm going to go ahead and add 360 to this. And when I do that, I get a value of 355.84 degrees. Okay. And then because I know that 720 is exactly 360 degrees away from 360, I know that I can add another 360 degrees here. and I'm going to get a second value that is within our domain. If you don't know that just from your number sense, go ahead and just add it. It takes very little time, and if it's not in the domain, great. If it is, even better. All right, so that is this solution. Oh no, that is this solution right here. These are our two solutions that we found. Okay, now we're coming over to our blue side. So I end up with theta minus 60 equals, I'm going to go ahead and do that math on the right. And that is, ooh, there should be a negative because that was a negative. I dropped my negative. Don't do that. So this should be minus negative 64. I end up with 244.16. And now I'm going to attempt to get theta by itself by adding 60. It's not really an attempt because I know how to do it. When I add 60, I get 304.16 degrees. That falls within our domain, and that is that part of our graph right there. So the only point that we have left to solve is this one right here. So let's go ahead and hop to that. And I'm going to do that by adding 360 degrees. When I do that, theta gives me 664.16 degrees. And we now have all four of our values. Remember, this one, negative 4.19, is not incorrect. It's just not within our domain. So that is not one of our four values. All right, make sure to subscribe to my channel for more math videos. I have several more trig videos coming out. Thanks for taking the time to learn math with me today. Till next time, remember, you've got this.